So how many of you have seen the universe? And have you ever asked, is it even real? Or is it? Wait, no, hang on, I think I messed up. Hey, Vsauce. Code Nerf Dart here. Apparently Fluid Sim wasn't hard enough, so we're doing a universe sim. And you would think I would be sane enough to stop after the hundreds of box colliders last time, but no. And I'm not just trying to make a universe simulator. You might think of starting at the molecular level, but I'm going all the way down to the quantum. Yeah, that level. Oh yeah. So you might be wondering, where should we even start something like this? YouTube. Yes. We should see if anyone else has code that we can learn from, Oh, well look, someone has already made this using a supercomputer and AI. Okay, well that clears everything up. Looks like our work here is done. Yep, this looks like absolute trash. Welp, in order to start a project like this, we're going to have to hit the books and really do some research here to understand the complexities and nuances of a graduate level quantum flytrap. Ooh, and with a few hints, we'll beam you on how to simulate quantum. Got it. Elements, board, entanglement. Ooh. What is this? Okay, back to Unity. Basically, quantum mechanics in a nutshell is that stuff is made out of stuff, but then that stuff is made out of stuff, and it's just stuff all the way down. So these are quarks. Let's just throw some of these in here. They come in pairs of 3. That sounds like an oxymoron. Your mom's a moron. No, you're a moron. Anyway, I made it so that they don't get too far from each other, and if we speed it up, they kind of look like those weird particle diagrams or something that you find while doing very important research. And if we put a whole bunch of them together, they make a beehive that runs away. So let's add a proton now. Red. And neutron. Okay, and then if you look really close, yeah, get in real close here. Yeah, neutrons are made out of... Too close. The neutrons actually still have a charge, but the charges cancel with the up and down quark, so it can still interact with protons and electrons. So I've added some electrons with a negative charge then to see that. And everything seems to be Oh, yeah, that's definitely wrong. Oh, and now my protons seem to be flying away. Okay, so when in doubt, just add more particles. Well, I honestly would call this a success. Look at that. We've got electrons, neutrons, looks like a nucleus is forming, and there's not really much else to do, so, you know, thanks for watching. You have no idea how long I've spent on this. Yes! So you remember last time with the GPU compute buffer? Well, unfortunately, I figured out how it works. And now we have 100 particles, 1,000 particles, 10,000 particles, 100,000 particles, 1 million particles, 10 million particles. Okay, I think this is as far as we can go here. And then all we need to do is add our old code and, oh, okay, I got it this time. Nope. Maybe making it white will help. Whoa, okay, we got it. Yeah, it's kind of bouncing, so let's zoom this in. Too far. I've got this bouncing problem because the frame rate stutters. No, go back. You've gone too far. Yeah, I call this one the Luke Skywalker atom. It's just kind of mesmerizing to watch, honestly. It looks like the particles are getting thrown out due to overcorrecting. And, oh, what's this? It looks like an atom. It's got like the electron fields and everything, like the, yeah, it totally has like the discrete energy levels for electrons. That is so interesting. Yeah, look at that. Uh-oh, it looks like I did something wrong. Okay, I somehow stumbled across this weird shape. Yeah, there it is. There are 2 poles, almost like a magnet. And if we color them... Oh, yeah, this isn't going to work. It just turns it red. We can see if the electrons are over here and the protons are over there. Okay, so we've colored everything. So it's the electrons on the outside. That's so weird. And there we go. We have it. Yeah, electrons here and protons there. Neutrons. And we'll get another close look. Yeah, and I like this because it actually looks realistic like the real world. Oh, I think I sent my protons into the stratosphere, and they're falling back down now. Yeah, I don't know if you knew it, but this is actually what protons really do in your body. They have a concert. And this just looks like the powder game now. I tried to increase the proton electric charge, but I think my code is backwards. They're attracting. Yeah, this isn't right. Okay, got it this time. More energy.
More the energy immediately, Mega Man.
Okay, so legally electrons weigh this much, which is equal to 0.00005? No, wait. Close enough. Honestly, wasn't expecting that to work. This totally looks like an atom. Yeah, look at that. Whoa. Okay, let's increase the charge. Oh. Okay, I've redone the entire GPU buffer, so now we have 3 individual quarks for each nucleon. Up quarks are red, I think, and down quarks are gray. And hey, I know it sounds like a kid made up these names, but you haven't even heard strange quark or charm quarks. Future Krafer here. I set the masses to the lab-tested values for each quark, but actually these aren't true because a proton, it's made out of 2 up quarks and a down quark, but the mass of a proton is more than the sum. I don't know how it works, but all I know is my simulation doesn't work. So the neutrons keep falling to the center. Okay, so next up, this has 3,000 particles in it, which means we have 1,000 nucleons, which is 500 protons. Yeah, uranium only has 92. This is way too big. Look at that thing. So we have to make the electric charge so strong that they split atoms. All right, this is my master plan. We have a curve. It's gonna go to 0 at some point, and that's gonna make the atoms split. And then I have to figure out how to write this as code now. Oh, and it actually works. Are you kidding? No way. This is actually so impressive. Okay, so let's see what kind of atoms form, like what sizes they are. Okay, so I have another issue now where they seem to drift apart. I've created a new curve. Wait a minute. Get that out of here. Okay, so I created a new curve. It doesn't go through 0 now. It just kind of tapers off like exponentially. And hopefully this causes like a gravity feature. And then back to coding. Got it. Okay, this is kind of crazy. Whoa, that is a huge atom. Okay, it's forming like these crystal structures in the center. Okay, so obviously these are too big. We gotta split it more. And I think these sizes look pretty accurate. Because what does this have? This has 1, 2, 8, 9. Okay, I lost count. I gotta restart. 1, 2, 30, 31, 32, 33 nucleons, which is like 15 protons-ish. I don't know. So what? That's like phosphorus. Okay, so I'm trying again with a bit smaller atoms too this time. And so when they get big this time, they should split. It's causing like a chain reaction. That's so interesting. This is like nuclear fission going on right now. It's like we have our own like CERN particle collider. Okay, so I've added electrons now. They have like almost no mass and they just fly through everything. So the electrons are causing like some extra instability here. That's so cool. And then on the large scale, it's so mesmerizing. That's so cool. Okay, check out this dude right here. It's a proton with an electron, which actually should turn into a neutron, right? Oh, that was violent. Yeah, these are so fun to just watch. Wow. We have a total like molecular system working now. We have a molecular simulation. So when the atoms get too big like this, they split, which is happening in our simulation. So this is totally like physically accurate. Okay, let's just add a whole bunch of particles to see what happens. Because, you know, the real world's made out of a lot of particles. And so this is our universe right here. It's going pretty good, and oh, it looks like it's disappeared. I've changed the rendering now so we don't render each quark, we just render the protons and neutrons. And then I've reduced the speed so it should look a little bit more stable here. We're looking for molecular structures in this. So it looks like we might have like, I don't know, yeah, hydrogen, and they're kind of connected by these like covalent bonds, it looks like. So I don't know what this is. This a molecule? This is a molecule. Yeah, it's a, I don't think this is a real molecule. Yeah, it's a lithium, that's aluminum. I like how this guy's just spinning. What are these? Hydrogen, helium, I think. These are some helium, hydrogen atoms. Yeah, wow. And then because we're doing it with the GPU, we can render so much. Yeah, okay, this is literally some molecular structure, kind of. Okay, what is going on here? oh, and then... Dang, look at that electron shoot out. Oh, and then these two guys... oh, no, never mind. Whoa, look at that. Totally formed like an actual structure here. Okay, so we have this atom, and it's gonna collide with this one. Oh, whoa. Okay, so we have this here, and it's creating this, which is, what is that, aluminum? So it's aluminum, hydrogen. I don't think that's how physics works. Okay, that's an interesting structure. It's got like 4 hydrogen atoms. Okay, so we're gonna increase the electrical charge here. Okay, these two guys, nope, never mind. This is such interesting like emergent behavior though. That's a big atom. Whoa, okay, and it just like ate that one. This is like a stable structure forming here. Yeah, look at these, like these are molecules. These are some actual molecules forming. I've started again with even smaller atoms this time. Yeah, okay, so definitely some like molecular structures forming. We got these. I'm seeing a lot more chains this time. Yeah, look at these. It totally develops like these complex shapes though. This is so cool. Okay, and then I've sped up a time lapse here so that we can see all the different interactions that happen. There's so many different unique structures that form. If you actually played with this, you could maybe create like a new chemistry out of this because it is 2-dimensional, not 3-dimensional. Okay, so let's bump it up one more time. Okay, and now we have some like grid structures forming, almost like constellations. Okay, and then this is gonna connect, and yeah, look at that. Oh, and there's something right here. What is this? It looks like it says that if you like and subscribe, you can see more videos like this. Wow, for the low price of free, you can get a steal of a deal. You know, as a hardworking man, you have to ask yourself, are you working hard or hardly working? Am I right? Well, come on down to the one-stop shop. What? Who are you? Oh, that's my timer. Gotta go check it. That's right, for just one payment of free $99, you can become a premium member of the Krafer Club. You get access to